This is going to be a not so thorough guide on how to install a base Arch Linux system. By base I mean, no desktop environment, just a basic base base system. Full disclosure, I am doing this on a virtual machine, and this is legacy BIOS, not UEFI. So wherever there's a difference, specifically in the bootloader and the partitioning phases, I will put an infographic or something in post to let you guys know. So let's begin. First up, let's check if we have internet. Ping any website. If you get an output like this, it means you do have internet. I would recommend you should install Arch with an Ethernet connection if possible. You can use Wi-Fi, but that's a little cumbersome, but there are tools that allow you to connect to Wi-Fi, such as WPA Supplicant or IWT. I have a stable virtual Ethernet connection, so we're not going to get into that. So now that we've verified our internet works, it's time for partitioning. So first up, run lsbulk to see what you're dealing with. So right now we have one 40GB hard disk. So let's open it up in cfdisk. Let's just run cfdisk/dev/sda. Basically, if you're on a UEFI system, you're going to want to create a GPT partition table. If you're on BIOS, you can go for DOS or GPT. I'm going to go for DOS because it's the simplest in my opinion. I will put an infographic or something over here, differentiating between what a partition structure on BIOS and what a partition structure on on UEFI should look like. Right now for BIOS we just need one swap partition and one root partition. So let's create a 4GB swap partition. Primary, set the type to Linux swap. And for the free space, let's use the rest of the space. Leave it at Linux, which is the default type. Now, before you write the table, make sure you know what partitions you're doing this on and what hard disk you're doing this on, especially if it's a computer that does not have a empty hard disk, or else you might lose a fair bit of data when you type yes. So now that the partition table has been written, lsbulk to verify the changes. We have two partitions now. So we're going to want to format them. Since SDA1 is swap, let's just run make swap /dev SDA1. That's done. Now we gotta set up our second partition. There are a different variety of file systems that you can use: BetterFS, XFS, ZFS. Personally, I prefer the tried and tested ext4. So mkfs.ext4/dev SDA2. And that's done. So now that our partitions have been formatted, it's time to mount them. First off, you're going to want to turn on your swap, which is simple enough. Swap on /dev SDA1. Now you want to mount the root partition to a suitable mount point. Let's mount /dev SDA2 to /mount. Right, so now we run lsbulk, and as we can see, swap is active and dev SDA2 is mounted to /mount. Now we're going to want to bootstrap our base system. The command is packstrap. So we specify our mount point with -k /mount, and then we specify whatever packages we need on the base system. So generally it's a good idea to go for base, Linux being your kernel, so you can use something else like Linux LTS. Let's just use Linux though for the time being. Linux firmware. And to simplify things, let's add a network manager and a text editor. So just put in network manager and vim. Now it's created and install root over there. It's refreshed its repositories, and it's going to take a few minutes to install everything. I'll fast forward to when it's done. The base system has been bootstrapped. Now it's time to generate our FS tab. This is basically going to create a file that instructs the system where partitions are to be mounted and what instructions they are to be mounted with, so -u /mount, and we write this info to /mount etc fstab. The -u flag links these partitions by their universally unique identifiers. So suppose you add another hard disk, SDB, or you remove a partition or something, there won't be any conflict by just the names. You'll have these things listed by the UUIDs, so that will save you a little bit of trouble. Cat mount etc/fstab to confirm the changes, as you can see here. Now that's done, you can chroot into the system by arch chroot /mount, and if you want, specify a shell. Now we are in the system that is installed on hardware, no longer in the live CD. So let's link our time zone first. lnsf, that's a symbolic link, user share zone info, and from this point just pick out your location, like say America, New York. For reference, I'm just gonna set it to UTC, and you link this to /etc/local time. Now that's done, you can set up the hardware clock. If your hardware clock is set to UTC, you can type in sys to HC, or the other way around if it's set to local time. It's generally a good idea to sync with an NTP server if possible, but I'm not going to cover that in this video. So let's just run this. Now the hardware clock is adjusted, it's time to set up our locales. So edit etc locale.gen. So this is a list of basically every single locale you have. Just hunt down whichever locales you want and uncomment those lines. I just want n_us.utf8. There it is. So we uncomment this line, right click, and run the locale gen command. That generates this locale. Now you want to edit etc locale.conf. This is a new file, actually, you're making a new one. Set the lang variable here. n_us.utf8. In my personal experience, I've seen if you don't set a lang variable, a lot of apps do not work at all. So that's quite an important step. Now that's done, you want to set a hostname. So vim etc hostname, and just type in any hostname you want. Let's call this Ravenhome.
That's the old passage to Ravenhome. We don't go there anymore.
Our hostname has been set. Now let's set up our root password. Just type in password. There's no password right now, so it prompts you to create a new one. Retype it, and now your root account has a password. Generally a good idea to set up a user at this phase right now. So just type in user add -mg. The M instructs the command to create a folder for this new user under /home, and the G instructs the command to add the user to the group that I'm about to add. So wheel. Wheel is basically a group that gives you some basic super user permissions. I'm not too sure, but yeah, generally a good idea to add users to wheel, and then you type in your username over here. So for reference, we'll just call this guy Anon. Now you want to set a password for this user, so password Anon, or whatever your username is. set a password, and we're good. Now all that's left to do is install a bootloader. So we're gonna go with grub. Again, this step is a little different depending on whether you're installing to a UEFI system or a BIOS system. On a BIOS system, it's fairly straightforward. Just grub install /dev/sda or whatever your main disk name is, and that should do it. On UEFI systems, it's a bit of a more complicated process. I'll add an infographic or something. But yeah, now that grub's been installed, we generate a config file, grub make config -o output to boots grub.config. Now at this point you're more or less done. You can take this time to install other things if you like, maybe activate a few services. Let's just install NeoFetch because, you know, it's Arch. How'd I misspell that? So yeah, just install whatever you need to install and exit the chroot environment and reboot your system. Now I've configured mine to boot directly into the CD, so we're gonna have to select the boot existing OS option. And this is the grub that's been installed on the actual hardware, or the VM in this case, but actual hardware. We're now booting into Arch Linux. You can log in as your user or root, whichever works. Let's log in as root and run NeoFetch. And here you have it. We have installed a very basic minimal Arch Linux system.